Enjoyment cadets, by the grace of Almighty, all of you are well wherever you are with your family. I hope you stay home, stay safe, and stay fine. In the COVID-19 pandemic condition, Boishal Cadet College arranged online class, and the class is going on. Dear cadets, you always maintain safety measures when you go outside from your house. I welcome you today's online class. I am Muhammad Saiful Islam, lecturer of chemistry, Boishal Cadet College. Of class 9, subject chemistry, chapter 5, name of the chapter, chemical bond. Dear cadets, look at the picture and think what will be the topic of this lecture today. Valency, radical, formula, and rules of writing compounds. These are the topics of this lecture today. At the end of the session, you will be able to explain concept of valence electrons and valency. You can write the formula of compounds, to explain stability of inert gas, to explain stability rules of atom from its electronic configuration, to explain causes of bond formation. Today's discussion, valency, valence electron, radical, writing the radical formula and way how to write the formula of compound, stability of atom and its electronic configuration, inert gas and its electronic configuration, causes of bond formation, different type of questions on our session. Key terms of this lecture today, valency, electron, formula, radical, stability, and inert. First one, valence electron. Valence electron are the electrons in the outermost energy level of an atom in its electronic configuration. Here, in case of bromine, this is the electronic configuration 1s2, 2s2, and 2p on. So, in the outermost energy level contain 3 electrons, and the outermost energy level is 2. So, the valence electrons are 3. In case of bromine, there are 7 electrons in its outermost energy level. So, in case of bromine, there are 7 electrons. These are valence electron. Valency. Another term, valency, the capacity of bonding with another element. Here in case of ammonia, here nitrogen combined with 3 hydrogen atoms. So valency of nitrogen is 3 and hydrogen on. Hydrogen is univalent element and nitrogen is trivalent element. So the capacity of bonding an atom with other univalent element is called its valency. In case of bromine, there are 7 electrons in the outermost energy level, 4s2, 4p5. These are the 7 electrons are called valence electrons, and valency of the bromine atom is on because it combined with another univalent element. Suppose HBr, hydrobromic acid. Electronic configuration of different element and its valency and valence electron. In case of hydrogen, electronic configuration 1s2, number of electron in outermost energy level on, number of unpaired electron on, and valency on. In case of lithium, valency on, number of unpaired electron in the outermost energy level on. In case of beryllium, number of outermost electron 2, so its valency 2. It can combine with other 2 univalent elements. In case of boron, there are 3 electrons in the outermost energy level, so valency 3. In case of carbon, there are 4 electrons in the outermost energy level, so it's valency 4. In case of nitrogen, 3. These are the valency and number of unpaired electrons in the outermost energy level. So there are 3 elements which are given. Now think what will be the valency of the elements. In case of magnesium, there are 2 electrons in the uppermost energy level, so valence 2 and valence electron 2. In case of chlorine, there are 7 electrons in the outermost energy level, so valence electron 7, but it can combine with other univalent element, so its valency on. In case of aluminium, its valency 3. So these are the valency after electronic configuration. In case of potassium, there is one electron in the outermost energy level, so its valence electron on and valency on. This is the potassium. Valency on, valence electron on. In case of sulfur, there are 2, 4, 6. These are the valency of the element. This is variable valency. It can combine with 2 elements shared with 4 electrons and also 6. So it shows variable valency 2, 4, 6. What is valency? This is the combining capacity of an atom with other univalent element. What is variable valency? If the valency of an element more than 1 from its electronic configuration and gain its stability, then this type of valency is called variable valency. Suppose in case of sulfur 2, 4, 6. Valency of different compound. In case of methane, valency of carbon 4, hydrogen on, phosphorus pentachloride 5, chlorine on, water, hydrogen 2, hydrogen on, oxygen 2. These are the valency of the elements in the compounds. Radical, a bundle of elements combined together acts as a single ion. This is called radical. Suppose hydroxyl group, ammonium ion, carbonate ion, sulfate ion, nitrate ion. These are the radical which acts as a single ion. Here sodium hydroxide, ammonium hydroxide, ammonium ion acts as a single element. Magnesium carbonate, carbonate acts as a single element. Calcium sulfate and potassium nitrate. Nitrate acts as a single anion. This is radical. There are some radicals and valency. Ammonium ion on, phosphonium ion on, hydroxyl group, valency on, carbonate 2, sulfate 2, sulfide 2, nitrate on. These are the charge of the radical and these are the valency of the radical which are given here. So this is the charge and this charge show as a valency here. Chemical formula of the compounds. By combining the valency of the elements which combine with each other and exchanging its valency form chemical formula. Suppose hydrochloric acid. Valency of hydrogen on, valency of chlorine on. They exchange their valency and form a neutral compound. In case of potassium chloride, plus on, minus on. They exchange their valency charge and they show the compound. This is neutral compound. Writing chemical formula of the compounds. Here, elements in the left side of the periodic table are written first. So metal are written first and non-metals are later. Valency of an element expresses its capacity of combining with other elements. So in case of hydrochloric acid, valency exchange, formula of compound written considering the valency of the elements, number of other elements with the ratio of the number of atoms with valency. If one atom valency 3, if another atom valency on. So the first atom combined with the other 3 elements This is the exchange their valency and they maintain the ratio. Suppose valency of hydrogen on chlorine ions, the ratio on compound hydrochloric acid. In case of carbon, valency 4, in case of hydrogen, valency 1. So they form methane by exchanging their valency and the ratio on is to 4. So CH4. So in case of carbon dioxide, they exchange their valency 4, 2 and the ratio on is to 2. Maintain 4, we need 2 hydrogen atoms. So carbon dioxide. In case of nitrogen pentoxide, so 2 is to 5. They exchange their valency and the formula of the compound N2O5. This is the nitrogen pentoxide. Here, in case of ions, copper ion 2 plus, sulfate ion 2 minus. So the ratio on and the compound is formula is CuSO4. In case of nitrogen phosphate, so their ratio 3 is to 4 because the charge and valency of the ion is 3. In case of aluminium and nitrate, aluminium 3 plus, nitrate ion on minus, so we need 3 nitrate ion combining with aluminium. So the formula of the compound AL-NO3 whole 3. So they exchange their valency and the compound is neutral compound. These are the structural formula. The formula which shown all the valency of the elements with other element is called structural formula. In case of formaldehyde, the valency of carbon 4, oxygen 2, hydrogen 1. So carbon combined with other 3 elements and oxygen, carbon, there is double bond. They show all the valencies of the elements in the formula. This is structural formula. In case of ammonia, nitrogen combined with 3 hydrogen atom and all the atoms are shown their valency here. Carbon tetrafluoride, so sulfur trioxide, all the compounds in the compound show their valencies. And this formula is structural formula, 3-dimensional formula. Octet and duet rule, the rule which is used for the stability of atom. Here, in case of octet, all the elements wants to gain the 8 electrons in its outermost energy level is called octet configuration. Here, sodium atom, it release an electron, gain the electronic configuration of neon, and in the outermost energy level contain 8 electrons. In case of aluminium 3 plus, it release 3 electrons and gain the electronic configuration of neon, and its outermost energy level contain 8 electrons, and it gets the stability of the atom. Duet, it gains the electronic configuration of helium and outermost energy level contain 2 electrons on S2. Here, lithium ion. It releases an electron and gains the electronic configuration of on S2 in the outermost energy level 2 electron, and it gains its stability. Cation, by releasing electron, atom gains the charge, positive charge. The positive charge containing ion is called cation. Suppose sodium ion, aluminium ion, and gain its octet or dual electronic configuration. Anion, by accepting electron, engage the electronic configuration of nearest inert gas and gain negative charge. Negative charge containing ion is called anion. Inert gas, there are 6 elements in the 18 group and they show the stability and gain outermost energy level 8 electron, and they does not want to react with each other. This type of elements are called inert gas. Helium, neon, argon, krypton, xenon, and radon. These are the inert gas and they does not want to react with another element. They are chemically inert and inactive. They does not want to combine with other element. These are inert gas and these are in group 18 elements. These are the electronic configuration of inert gas. Here helium 2, this element follow duet electronic configuration, neon, argon, krypton, xenon, and radon. This element show 8 electron in the outermost energy level and it show octet electronic configuration and gain its stability. These are the electronic configuration of inert gas. Here helium 2, neon 10 to 8, argon 18 to 88, krypton 36 to 8, 18, 8, xenon 54 to 8, 18, 18, 8, radon 86 to 8, 18, 32, 18, 8. So all the elements show 8 electrons in its outermost energy level and gain its stability, except helium. It follows duet electronic configuration. Chemical formula of the compound. So by following 8 electrons in the outermost energy level and exchange the valency of the elements, the chemical formula is written. Suppose in case of carbon dioxide, the valence of carbon 4, valence of oxygen 2. So the formula of the compounds CO2. By exchanging their valency, we need two oxygen atom to maintain 4 valency of carbon. So we need 2 oxygen atoms. So the ratio 1:2 of carbon dioxide. So this is the molecular formula of carbon dioxide, CO2. Causes of chemical bond formation. Mainly, chemical bond is formed by getting stability or nearest inert electronic configuration. So to gain stability, chemical bond is formed by combining with other elements. Some dear carriers, causes of chemical bond formation. Chemical bond is formed due to gain its electronic configuration of nearest inert gas and duet electronic configuration. Also, finally, they gain the stable electronic configuration and get stability. Now, here 3 elements are given: nitrogen, fluorine, and calcium. Valency and electron configuration of the elements you need to write. Here nitrogen, there are 5 electrons in the outermost energy level. This is the valence electron and valency of nitrogen 3. Fluorine, 7 electron in the outermost energy level. Here fluorine, the electron number 9 and its valency on, because it combined with other univalent element. In case of calcium, there are 2 electrons in the outermost energy level from its electronic configuration, and it combined with other 2 univalent elements, so its valency and valence electron same. This is the 2. Several types of questions may be set from our discussion: knowledge-based question, understanding level question, application-based, and higher order. First one, knowledge-based question. What is radical? The ion, bundle of elements which acts as single ion. Cation, positive charge containing ion is called cation. It is formed by releasing electron. What is valency? This is the combining capacity of another univalent element. Second type question, valency and valence electron. There are some differences between valence and valence electron. In case of valence, no charge is used, but in case of valence electron, this is the number of electron in the outermost energy level. In case of valence, this is the unpaired electron. Explain the formula of sulfuric acid. It is H2SO4. The charge of sulfate ion -2, and in case of hydrogen on. So valency of sulfate ion 2 and valence of hydrogen on. So we need to maintain ratio 2:1 to neutralize the valency and charge of the ions. So this is the chemical formula of sulfuric acid, and it is H2SO4. Third type question, higher order base. This is the electronic configuration of element NH2 NP6, the outermost energy level, and value of N, that means principal quantum number 3. So elements is argon. Now electronic configuration of argon you need to write and discuss its valency is 0. So because it does not want to combine with any other element. Here, this is the argon. And question is, it does not want to combine with other element because it gains stability, and in the outermost energy level it has 8 electrons, so it does not need to combine with other element for gaining stability. It is stable element. There is a creative question. There are two elements are given. One is aluminium, another is argon. So 4 questions here. What is formula? By exchanging the valency of the element, the combined atom is called formula. Show the formula of phosphoric acid H3PO4, and it show valency on 3 because the valency of phosphate ion 3. Electronic configuration of A and B. This is the aluminium 1s2 2p 6 3s2 3p on. This is the argon 1s2 2p 6 3s2 3p 6. One of the elements in the system does not want to form bond because one of the element, that means B, is inert element. It does not want to combine with other element. It is also stable element. If any question, you inform me. In the next class, I will solve it. Dear cadets, it is very crucial time we are passing. It is coronavirus pandemic condition. You always maintain safety measure for your betterment and for your safety. You stay home, stay safe, and stay sound with your dearest and nearest family members. Dear cadets, in the next class, we'll discuss about different bonds and its properties and formation of bonds. Be fine. Thanks a lot.